Right. I welcome you back. This is Mr. Hyper, and I'm taking you through the examples of steam distillation that this time involve the plotting of graphs. So in this example, we are told that the vapor pressures of water and that of substance A at different temperatures are given in the table below. So you're having temperature, vapor pressure of water, and vapor pressure of substance A. The question is saying that on the same axis, plot graphs of vapor pressure against temperature for water and substance A. Then after plotting the graph, they are saying that when A was distilled in steam, showing that it is steam distillation at 1 atmospheric pressure, the temperature of distillation was 97 degrees centigrade, and the distillate obtained contained 4.29 grams of substance A and 1.1 gram of water. Using your graph, determine the relative molecular mass of substance A. So the main important thing is to first plot a graph of vapor pressure against water, against temperature for water and those substances. Now, first have a question written on your book or anywhere else, so that when we are plotting, we do not keep turning back. So for that part A, of course, the first important thing is to first put a title. So you're going to say a graph, right? Graph of vapor pressure. You have to write all words. Graph of vapor pressure against temperature for water and substance. So if you look at those values we are given, the vapor pressures, the smallest value is 0.22, or the highest value is 0.63. So I can and here, since temperatures, we have 20, we have 40, we have 60. Another temperature is 80. We have 100, but we can move up to 120. Then, so this is the temperature in degrees Celsius. Then we have got pressures. We can start from 0.2, can go to 0.3, can go to 0.5, we can go to 0.6, we can go to 0.7, maybe up to 0.8 appropriately. So this is the vapor pressure in atmospheres. So you plot. You're going to find that for A, the graph will be like this. You use a dot and a circle, a dot and a circle, a dot and a circle. If some points do not lie, of course, all points may not be in a straight line, but there you can draw the line of the best fit. Maybe you can have a case like this, something, can have something like this, have something like this. So you plot appropriately, you find yourself having something like that. Then this is the vapor pressure of A. Then for water, you may have something like this, or something like this, depending on your plotting. So still, as I've told you, you may find not all values in the straight line, but you plot one by one, you will say vapor pressure of water. Now, those are the 4 marks they had told us. Now, you make sure that you plot appropriately. Here, I'm doing this because I want to show you how we get the values from the graph, but you can do better. From there, they are saying that when substance A was distilled in steam at 1 atmosphere, the temperature of distillation was 97. And the distillate obtained contained 4.29 grams of air and 1.1 gram of water. So we have mass of air and mass of water. So what else do we need? We need a vapor pressure of air and vapor pressure of water. To get to those vapor pressures, we need to come and look at 97. That is the temperature of distillation. They said that the temperature of distillation was 97 degrees Celsius. So we are going to check for 97, which is the temperature. Maybe if this is my 97 on the graph, this is the temperature of distillation. We are going to correspond this temperature to these graphs of vapor pressure. The vapor pressure which you read on this axis will be corresponding to the vapor pressure of water. Okay, so we shall need the vapor pressure of water, which you can read direct by corresponding at the temperature. So that value there, I want you to see if you get 0.385 atmospheres. Then vapor pressure of air, still we shall continue. You continue, and then you correspond. However, it is too far, but it is supposed to be around 0.6 something. So I want you to correspond and see if the value you read would be. So you make sure that you correspond this point of temperature to each of the graph, and then you read the vapor pressure. So I want you to find out if you find that the vapor pressure of air is 0.62 atmospheres. Now, by having mass of air and mass of water, vapor pressure of air, vapor pressure of water, you know the molecular mass of water, you can substitute in the formula where we have that mass of air over mass of water is equals to vapor pressure of air times molecular mass of air over vapor pressure of water times the relative molecular mass of water. This formula, when substituted like the way we're doing, is going to give you the value accurately that you want. Then there is another question that I want us to go through, the question which I want to give you highlights on. And this question was about questions were like the following. The following data was obtained for the steam distillation of bromobenzene at 760 millimeters of mercury. Now this is the main thing. 760 millimeters of mercury. So we have temperature in degrees Celsius. We have the pressure of water, millimeters of mercury. We have the pressure of bromobenzene in millimeters of mercury still. We have 90, we have 92, we have 94, we have 96, we have 98, and 100. We have 526, 96, 567, 106, 611, 114, 658, 123, 707, 132. We have 760 here, 141. The question is, on the same axis, plot graphs of the pressure of the mixture and each of the component against temperature to determine the boiling point of the mixture. Then 3, the third part is calculate the percentage of bromobenzene in the distillate. Calculate the percentage of bromobenzene in the distillate. So now, looking at this question, they are saying that on the same axis, plot a graph of vapor pressure of the mixture. Vapor pressure of the mixture. So what you have to first do is to first get the vapor pressure of the mixture. And how do you get the vapor pressure of the mixture? You have to add those vapor pressures of each component, because to get the vapor pressure of the mixture, okay, you have to add the two. So what we are going to do, we're going to strictly, you can redraw that table. You draw the table, you'll have temperature. The temperature will keep the same way as it is, degrees Celsius. You'll have vapor pressure of water, which will keep the way it is. You have vapor pressure of bromobenzene, which will keep the way it is. Then you have to add vapor pressure of the mixture, because they are saying that plot the graphs of vapor pressure of the mixture and each of the component against temperature. So you'll be adding a vapor pressure of water and bromobenzene you get for the mixture, like that. So on adding them up, here you'll have 622. When you add 567 and 106, you'll have 673. When you add the next ones, you have 725. When you add these ones here, you're going to have 781. You add the other ones, you get 839 and 901. So those are the vapor pressures of the mixture. Now, after doing this, here you've gotten the vapor pressures of water and the one of bromobenzene. So after doing this, we go ahead now to plot. We shall plot for the mixture, we plot for bromobenzene, we plot for water, and everything against the temperature. So what we do, like we did in the previous one, you're going to plot put a graph, or rather a title, graph of air pressure of the mixture and each of the components against the temperature. That is what you need first, right? A graph of vapor pressure of the mixture and each of the components against temperature. So here you have vapor pressure is appropriate scale. Here you have temperature. Now, On plotting that vapor pressure of the mixture, you find the one of the mixture, of course, will be on top of them. Then you plot the one of water. The one of water may follow like this. Then one of bromobenzene, because it is low, you may find it like that. So you are going to come up with something like this. So we have vapor pressure in degrees Celsius, rather temperature in degrees Celsius, vapor pressure in millimeters of mercury. I want everyone to do this by you yourselves, and you see the values you will get. So if they say that to determine the vapor pressure, rather the temperature, they want us to determine the temperature. The question is determine the boiling point of the mixture. To determine the boiling point of the mixture, you first look at the vapor pressure of the mixture. The vapor pressure of the mixture is 760. So you'll come to 760. You correspond where it meets the curves, and it is from that point that you're going to correspond. The temperature you read here will be the temperature for the, it will be the temperature for the what? For the mixture. It will be the temperature for the, it will be the temperature for the mixture. And that temperature, you are going to get it as, you're going to get it as what? You can do it, the boiling point of the mixture will be obtained as something like, but I want everyone to plot, and then you determine that temperature by you yourselves. Okay, so you're going to determine that boiling point of that mixture by yourselves. So after getting the boiling point of the mixture, they go ahead to ask, that the percentage by mass of bromobenzene. We can let percentage by mass of bromobenzene be X. For bromobenzene, if you let it to be X, then it means that for water, it's going to be 100 minus X. This is for bromobenzene. This is for water. Then from the graph, you can get the vapor pressures of each. You get the vapor pressure of bromobenzene, which you read off from here. Remember to label your curves. If this is vapor pressure of bromobenzene, you write it there. If this is for water, you write it there. If this is for the mixture, you write it there. Vapor pressure for the mixture, vapor pressure for water, vapor pressure for bromobenzene. Now, vapor pressure of bromobenzene from the graph, you can read and find out if you get 157 or roughly that. Then for water, you try reading and see if you get 6040 millimeters of mercury. Okay, so you have masses, so you can substitute now. Still, since you know bromobenzene, you can get its formula mass, molecular mass of bromobenzene, because now since they need the percentage composition, they need the value of X, so you need to be knowing the molecular masses. So molecular mass of bromobenzene, you can get it. Bromobenzene is C6H5Br. You get its molecular mass as 157 by getting carbon as 12 times 6 plus hydrogen, which is 5 times 1, then plus bromine, which is 8, you'll get 157. Then the one of water is 18. Then now we substitute mass of bromobenzene over mass of water will be equal to vapor pressure of bromobenzene times molecular mass of bromobenzene of vapor pressure of water times molecular mass of water. You'll end up getting, you'll have X out of 100 minus X is equals to the pressure of water. You substitute rather bromobenzene, 157. That is the molecular mass. Then even the vapor pressure of bromobenzene is supposed to be 120. From the graph, see if you get 120. So times 120 out of 640 times 18. Then you solve for the value of X and C. If you get 62.02% as your percentage composition of bromobenzene. So I wish you all the best. You practice these things, you do them, you draw these graphs using your graph papers and see if you can graphically show this. I wish you all the best. Now we are going to be meeting in the 3-component phase where we're going to look at the distribution law, after which we shall conclude with eutectic mixtures and we call it phase equilibria.